All right, say if I'm given a circle, and I'm taking this out of the book, it says try number 8. I'm given a circle. They said my radius, again, is 10 centimeters. But I want my angle to be (215 degrees). What is this arc? And I know my circle is not drawn like a circle, looks more like an oval. But how much is that portion of the circle? What is that measure? Again, one formula, S is equal to radius times my theta. My theta must be in radians. So if I have 215 degrees, I'll say 215 degrees over 1 times pi divided by 180. And if we do the math, you get, excuse me. If you reduce it, you would get 43 pi over 36. If you don't believe me, 5 will go into both of them. You know, 5 will go into 20 4 times, 5 will go into 15 3 times, 5 will go into 18 3 times with 30 left over, 5 will go into 36. So you get, so now I have my radians. I can use this formula. I can say that is just going to equal to, so S is equal to my radius, which is 10. Again, because this is a fraction, I make that a fraction, times 43 pi over 36. You know, both of these are cancel out because the 5 is, the 2 will go into this 5 times and 2 go into this 18 times. Of course, you should know what 5 times 243 is, 43 is. So you should get 215 pi over divided by 2 over 18. Again, you have your calculator. You can go ahead and use your calculator to find it. Excuse me. That was one of the ways we can do it. Or the way, like I said, we know we're looking for an intercepted arc. We're looking for the angle. That's the same thing as saying A over 2 pi r, because now he's converting it to radians for me, is equal to my central angle, and we'll call that CA, just abbreviate, over how many degrees on a circle? 360. These two are automatic because we remember those enough. Now we just fill in the gaps. A divided by 2 times pi times 10 is equal to 215 divided by 360. Again, doing the same math, times multiplying by 20 pi, and that will get that formula. How many times 20 going, or how many times 2 going to 10? So we know that's, excuse me, 18. So we said that is equal to 215 pi over 18. Either way, we're going to get the same answer. So I'm not telling you one way is better than the other. I'm just giving you a different look. So once we do that, and then you'll have some questions and you'll have to ask me. Let's look at finding the arc. Let's look at finding the sector area. And the sector area, if I scroll down a little bit. Here's the sector area formula. Look, they notice they want to use 1/2 theta times radius squared. And again, theta will be measured in radians. So if they give us degrees, we got to convert it to radians. Or we can also, excuse me, use a different formula. But let's look at this question. They gave us example 9 in the book. They want us to find the sector area, and they want to say the water is sprinkling on the grass or the lawn. It's a 30 degree spin. It's spreading at a 30 degree angle for 20 feet.
What is this area that is covering?
Oh man. Well, here's a small slice, 30 degrees at 20 feet. So instead of using this form, this is my area. So this is the sector area. Area, you know, is going to be in square units. Area would be, so the sector area is equal 1/2, and then use a capital A instead of the S. Theta, which is measured again in radians, times R squared. 1/2 theta R squared. Again, there's two ways we can look at it. If my theta is 30 degrees, 30 degrees is equal to what is pi radians? Well, we understand that as 30 degrees over 1 multiplied by pi divided by 180, which is pi over 6. So we know that is pi over 6. So now using this form, you says S is equal to 1/2. My theta is pi over 6. My, excuse me, R is 20 squared. Order of operation says parentheses then exponent, so you're going to take 20 squared, that's 400. Half of 400 is 200. So you have 200 pi over 6, which you know 2 can go in that can be 100 pi over 3. And because 3 and 3.4 are close to each other, you take your calculator, you know it's going to be in the area of 100, excuse me, of 100 and some left over. Excuse me. But since we got that, this is another way we can look at it. Again, I told you there's one way. If we don't come up with the same answers, then one method is better than the other method. No, they're not. They're the same. But it just gives us another way of looking at it from a geometry standpoint. We know sector area, of course, instead of we find in the intersected arc, we find in the SA sector area over. Now, what's the formula for area of a circle? It's not 2 pi r, it's pi r squared. So because the area of the circle, you know, the ratio of the area over the sector area over the total area is equal to, again, we need my angle, my central angle, which is 30 degrees over, again, how many degrees in any circle, no matter how big or how small, 360 degrees. So now we're looking for this. If you want to use SA, radius we said was 20. So 20 square pi, excuse me, is equal to my central angle, which we said was 30 degrees over 360. Again, by doing the math, you know that's 1 over 12. So SA over 400 pi is equal 1 over 12. Multiply both sides by 400 and pi. Don't forget my pi. 400 pi. You know, 3 are going to both of those. Excuse me. 4 are going to, how many times 4 going to 400? 100 pi. How many times 4 going to 12? 3. So it doesn't matter which way you look. You should have the same answer. So whether you want to go ahead and know it as the ratio or if you want to use the formula. But once you use the formula, it's important that you convert your degrees into radians. Without them being in radians, you're not going to get the same answer.